Okay, we know that frequency of the sound wave is an objective quantity that can be measured and depends on the source. How many times source is vibrating, sound wave produced by this source will have the same frequency. Assume that there is a horn in a disambulance, horn. How many times it's vibrating this horn, sound produced by this ambulance will have the same frequency of this horn. This is objective quantity, which means how many times horn is vibrating, the sound produced by the horn will have the same frequency. But pitch is something different. What is the difference between that? Pitch is how high and low we perceive, or human being perceive the sound, is known as the pitch. So a sound is produced by a source. Of course, how many times source is vibrating, sound has the same frequency. However, as sound travels in air, reaches your ear, sometimes some people at some conditions can hear these frequencies of this sound, can perceive the sound as at some different frequencies. I mean, the source can have a different frequency. This person can hear a different frequency. That's why we say that pitch is subjective to the listener. And listener can hear a frequency different than what original frequency is. So that's why it's defined as how high or how low human being perceive this sound, known as pitch, and it's a subjective to listeners. So the frequency perceived by a listener, as I said, it's called pitch, depends on four things. Yeah, and four things can make you to perceive, to detect a sound different than original frequency. One of them is frequency of the sound. First one is not different. Of course, frequency of the sound is important. As frequency of the sound increases, so you are going to hear a higher pitch. This is normal. This is normal case. This is not subjective to someone else. However, as frequency changes, if ambulance changes its sound, so then you are going to hear a sound with a different frequency. But there are other factors which can be subjective. For example, loudness. What does this mean, loudness? Sometimes if loudness, power, volume of a sound increases, human being can detect that pitch has changed, or they can think that pitch has changed. In fact, pitch frequency of the sound does not change. You get this frequency, you think that it's increasing, you think that it is decreasing if the volume decreases. Loudness is one reason how we think the sound is changing. Now I am going to show you a present program. This program is making a sound. Normally, it's Android application, but you can use all Android applications in your computer by using some emulators. So this is an emulator known as multi-drive Knox. So now I'm going to make a sound by application. So then how pitch changes, what does pitch means, I will try to explain to you in here. So this is frequency generator. So we are going to generate the sound at different frequencies. This is a sound at a frequency of 440 hertz. So as source increases the frequency, you start hearing a sound which is at higher pitch. This is called, what you hear is called pitch. But as frequency of the source changes, pitch is changing. What you hear is changing. As you see that as frequency increases, pitch, what you detected sound also increases. But now I will do something else. I will talk about the volume now. I will get a little low volume sound. As I am increasing the volume, you can think that pitch is rising. It's getting thinner and thinner. In fact, it is not. We don't change the frequency. This is the lack of all human hearing. Frequency is the same. Only I increase the volume, loudness. As sound get louder, human ear can think that frequency is increasing, but in fact I didn't change the frequency. I only increase the volume. I only increase the loudness. Because we are not perfect machines. We are created with some deficiencies in the ear, in the eye. Second one is that yani when the loudness increases, human ear can think that pitch is rising. In fact, it is not. This is used to this experiment. Third one is background noise. If two sound mixes each other, you can think that, for example, you are listening to music and then nobody is in the room, and you are listening to music, or somebody is blowing an instrument in this music. But if somebody enters the room, everybody makes the noise, or a classroom. Think about that. This time, human being can detect the same sound at different pitch. It's another thing. And background noise. If someone else is talking in your room, you can perceive the sound at a different frequency, at different pitch. So these are not measurable. We cannot measure these two. Yeah, but we can know that yes, loudness. If you make it sound louder, so it's possible you can perceive the sound at a higher pitch. Or if somebody is talking in the room, if you are in a noisy environment, in this case, the same sound can be detected by different pitch. These are not measurable. But there is one thing we can measure: relative motion between the sound source and the listener. This ambulance is moving towards the observer, you, or moving away from you. In these cases, we can measure what frequency your ear detects. What is the pitch you heard? So it will be different than that, but how much? We will calculate it. Now I'm going to show an experiment to you. Maybe you observed this in the life as well. Now you are going to see that a car is horning, continuously horning, but approaching to you. And after that, it passed by you. After passed by you, you are going to see that suddenly pitch is shifting. Watch it now. In fact, a car is holding the same frequency. Car didn't change something. But what happened? When it was approaching to you, you heard a high pitch. When it starts moving away from you, you heard a low pitch. The same thing can be observed by an approaching ambulance or train vessel. Even source didn't change the frequency, but relative motion between the sound source and observer. If there's a relative motion, what does relative motion mean? If two objects approaches each other or moves away from each other, this is called what? Relatively they are in motion. So you can observe a change in perceived frequency. You can observe a change in pitch from original frequency. So original frequency is different. What you detected is different. They are different frequencies. So this frequency shift is known as Doppler effect. So this is minister exam question. Whenever there's a relative motion between sound source and observer, there is a shift in frequency, detected frequency. This phenomenon is known as what? It's known as Doppler effect. Maybe the first scientist who talked about is the Doppler. That's why his name is given to this event. So that's why we can say that relative motion, yes, the key is this: there must be a relative motion between the source and listener. These two objects, source and listener, must relatively approach each other or relatively move away from each other. So this is the key. Relatively, they must approach each other, and relatively, they must move away from each other. If the sound source and listener are relatively approaching, listener observes or perceives a higher frequency, higher pitch, hears a higher pitch, detects a higher pitch. But if sound source and listener are relatively moving away, like the car moving away from you, in this case, listener or observer perceives a smaller frequency or lower pitch. Reason is that, in fact, it's very similar to breaking sound barrier. When, for example, ambulance, when ambulance is approaching this observer, you see that wavefronts in front of the ambulance get shorter. When wavefronts get shorter, which means wavelength gets shorter, is it? Because the separation between wavefront is the wavelength. But speed of the sound in air is constant. So equation is what? Lambda times f. Because v is constant in air, because the wavefronts get closer because of the motion of this ambulance, so wavelength gets shorter in front of in this region. And this observer hears a sound with a shorter wavelength than actual. If this wavelength is shorter, what does it mean? Frequency must heard higher. So wavefronts get shorter, wavelength decreases, frequency of the pitch rises in here. But when the ambulance is moving away, this time observer is at the back. And wavefronts are getting farther from each other, which means wavelength detected by this observer is longer. So longer than this one, this case. So V is equal to lambda times F again. Because this observer detects a higher wavelength, so then frequency must be detected as lower. That's why then this observer, when the car is moving away, so detects as sound which is at lower pitch. This is what Doppler effect is. So there is an equation to get the frequency of the pitch. So the equation for calculating perceived frequency, when I say perceived frequency or detected frequency, we are talking about the pitch. So perceived frequency or detected frequency. If question says that, like this, I will say detected. Even all the problems, detected. Detected frequency means pitch. It's talking about the pitch. There is an equation. Yes, there are two frequencies we have. One of them is original frequency, F. Second one is detected frequency, pitch. This is original frequency. Depends on the source, how many times the source is vibrating. So then wave is frequency is that. Second one is F prime. F prime is pitch frequency of the pitch. This is pitch. This pitch changes according to the relative motion between the observer and the source. But when we are talking relative motions, in some problems, source is going to move, like ambulance is moving, as in here. But it is also possible ambulance is at rest, but you are moving. You are running. You are running across the ambulance. This is also possible. So in this case, there is also relative motion between ambulance and observer. For that reason, in your equation, there are two variables. One of them is the observer speed, if it is moving. Second one is source speed, if it is moving. And equation is going to be V plus minus. I'm going to teach how to get that it's plus or minus in the problem solution. So V is the speed of sound. It is constant. For example, in air, it is 340. It will be given to you. Don't worry. V will be given, speed of sound. Observer's frequency, VO, source frequency, VS. So plus, it will be sometimes plus, sometimes minus. It will be sometimes plus, sometimes minus. So we are going to get the pitch frequency by this equation. A police car moves at a speed of 90 km per hour, emits a siren. Siren is a sound that police car makes. Siren of frequency 1000 hertz. So then source has a frequency, original frequency, 1000 hertz. And then source is police car. Source is moving at a speed of 90 km per hour, VS, V source. Let's record it. Source, 90 km per hour. Okay, let me change the color of pen dark. Okay, and emits a siren of 1000 hertz, original frequency f. What is the frequency of the sound as detected by? Yani talking about this sentence is saying you this definition. Question f prime. What is f prime? What is frequency of the sound as detected by a standing observer? Oh, standing observer. Observer is at rest. So we observer is 0. So we don't need to care about the observer. 0. Standing. As the police car approaches, oh, this is the key. This is important key. Approaches. So calculate f prime. But approaching case. So what do you think? F prime and f. Which one is going to be greater? F prime or f? F prime must be greater than f. It's going to be greater than 1000. So how much? We will get it now. But first we should convert kilometer per hour to meter per second because kilometer per hour is not SI unit. We have to convert kilometer per hour. How? We know that every kilometer per hour is equal to 90 multiplied by every kilometer is 1000 meters. Every hour, how many seconds? Each hour, 3600 seconds. So you are going to multiply by 1000, divide by 3600, or directly you can divide by 3.6. It's also possible. So 90 multiplied by 1000 divided by 3600. 25 meters per second. F prime is equal to F multiplied by V plus minus VO. No need to write this because VO is 0. I'm not going to write VO in here because it's 0. And plus minus has no meaning. But in denominator, now be careful. It is positive or negative. I'm going to determine that. Okay. I know that F prime is greater than F. To make F prime greater than F, I should make here negative or positive. What do you think mathematically? Think that. I want to make F prime greater than F. To make this denominator must be smaller. That's why I should subtract it. V minus Vs. So in this case, I can get F prime greater than F. If I make it positive, this time F prime will be less than F. This is not correct according to this question. Now I will calculate F prime. F prime is equal to F is 1000 multiplied by speed of sound in air is given as 340. It will be given in the question, don't worry. And 340 minus 25. Bracket. Answer is 1080. So frequency detected by the standing observer is 1080 hertz. Is it correct according to this one? Yes, because 1080 hertz is greater than 1000 hertz. Yes, I got the correct answer.